Oh, right. Well, I wasn't going to start doing this tonight because I was just so tired. But yeah, I mean, it's just a resistor capacitor for the uh, low side, low frequency, and the other way around for this. Well, it's a resistor, then a capacitor to ground, and for the high frequency, we have the capacitor then to the resistor to ground. It's the other way around, basically, for high and low pass filters. It's just passive. It's perfectly basic, and obviously because it's just passive, we don't have a massive amount of transitional gain. So it's a gradual process. Anyway, I've got my signal generator running, but it's running at 12 volts. It needs 15 volts, and my charger's running something at the moment, so yeah, can't really run it on there. So I'll have to sort the lead out and plug it in or something in a minute or two. But anyway, I've got the oscilloscope hooked up to my filter, and the yellow is the high frequency, and the blue is the low frequency. And I can't get the frequency low at the moment, but you can see I've got the basics of it working. So we're in the minimum frequency right now. Blue and yellow is pretty equal. I'm only at 30 hertz though, so I really want to be lower than that because the generator starts at obviously 1 hertz and it goes up to whatever. Yeah. So if I adjust it, you'll see that what happens with the blue starts to disappear as the frequency goes up. The yellow basically stays up. The high yellow is high frequency, and that's a little bit too high frequency right now, but I've only just started working on it. As I turn it down, you see the low frequency comes back and the yellow starts to fade, but I can't turn it all the way down because I'm stuck at 30 hertz. So I need to sort my frequency generator out or something because I can't get lower than 30 hertz. And I think I remember why. It's because when I was doing audio work, when I was doing audio stuff related work, we didn't really need anything lower than 30 hertz anyway. But I need it now. Yeah, please give me 30. Give me lower than 30 hertz. So yeah, I'm gonna have to sort my. I'm gonna have to open the lid up and piggyback a capacitor on it or something. On one of the capacitors that's in there, I'll just have to piggyback an extra capacitor and to bring the frequency down. I've already had the lid off earlier tonight because the pot was a bit mucky. The volume, the adjustment of the frequency was a bit twitchy, and it kept my waveforms were jumping around, so I had to squirt some stuff in there to sort that out. And yeah, I don't want to take it apart again. But anyway, I'm pretty sure it's going to work. Anyway, what I can do, actually, rather than mess around with a frequency generator, what I can do is simply tap the signal directly from the generator, feed that into my circuit, which is what would be driving anyway. Obviously, the higher voltages. So, yeah, that's another way I could sort this out. I could simply tap. I've got some extra coils at the top here, which aren't connected to anything at the moment. These two at the top aren't connected to anything, so I pop them in for testing. Those two coils there, they're right at the top there. They're not. So what I can do is run some wires from one of these coils down to my circuit, and then run my generator at really low speeds. Do some testing that way, which saves me messing about with my single generator, doesn't it? Yeah, so that's probably the next step, really. But nothing else to show you. I mean, I told you it's simple. It's just passive. There's nothing much there. But to get a bigger transitional gain, you know, when it went a faster roll off of one frequency and a faster roll on of the next frequency, it would have to be active. You know, we'd have to use some op amps and things like that. And yeah, I really don't want to get into op amps. I've got one on here actually. L833N. I've got a few chips on this breadboard. I often keep them handy in case I need them. Well, I could obviously use an op amp, but I really don't want to start doing that because, as I say, every time you add more electronics circuit components, you're using more power, aren't you? So I mean, yeah, I don't think I really need it, to be honest. I mean, I've got a and the other thing about this transitional wave, you know, where you have a high pass and a low pass, is that both signals will basically go into a mixer. I didn't mention this previously, but a mixer, as in, well, a mixer can be anything. It can be just a stage where the two signals come together, basically from the two trigger pulses, because they're both going to be driving the same MOSFET, and whichever is the strongest pulse will take precedence and will basically turn the MOSFET on to do the pulse work, you know. So, for example, let's say the low frequency is stronger than the yellow frequency, then that pulse, if it's slightly higher, would be the first one to do the triggering. Obviously, once it's triggered, even if the yellow pulse arrived a millisecond later, it wouldn't matter because it was already on, if you see what I mean. But if the blue pulse, if the lower frequency was lower in amplitude and wasn't strong enough to trigger the MOSFET, then the yellow pulse would trigger it. So I'm not too worried about the fast roll on, fast roll off and all this stuff, because just the slightest difference in the gain between the low frequency, the high frequency, the waveforms, when they get to the mixer will basically discriminate and use whichever pulse is strongest to do the active work. So I'll have a gain control on there somewhere. So that the mixer will simply, I'll probably use an opto isolator actually, which turns an LED, but I'll need probably. I don't know if I need a transistor. I might do it. That will make it active though if I do that. But I need something that will basically receive that signal and do the turn on, turn off to drive the MOSFET. So I need something significant to drive the MOSFET. I could use a simple transistor to drive the MOSFET. You know, just a simple. Like a Darlington configuration basically or something like that, but yeah, we'll see. Anyway, I don't know yet. I'm still thinking, I'm still working things out, you know. It's all ad hoc at the moment, it's all up in the air basically. I'm just trying a few things out with my filters and my bandpass filters, and yeah, I'm not decided 100% on anything yet, because I've got to work this out before I actually design a circuit board, and I don't want to start designing a circuit board until I'm happy with what I'm going to be putting on it, you know. These pass filters, they're fairly simple, but they're a pain in the ass when you're trying to get the right frequencies. That's the thing, it's getting the values. And this capacitor is only a 1 microfarad, and this one is 4.7, I believe. Yeah, I've got a bunch of them, so I'm trying to use the electrolytic type things. I could use lower value like ceramic discs and things, but you see, it has to be in a current range that's able to drive an LED, because the that board I was showing you the other day, that hang on, let me get it again. If I can grab it, can't quite reach. Oh. Right, this board that I got from China a few years ago, which has got my lead stuck on it. I showed it the other day. It's already got a MOSFET on there, and it's got an opto isolator already on the board, and it's triggered by an LED and a resistor in series with the with this op amp, this opto isolator. And so obviously the current has to be strong enough to drive the LED and the opto isolator, which is already on this board that I got from China. So I have to keep my current fairly high, so that's the reason why I'm using electrolytics. If I use high impedance, I can't use this board anymore without using an amplifier stage, and that's what as I say, I'm trying to avoid doing that if I can. So I have to use electrolytics because they've got enough drive from the coil to drive the LED on this board, because I've already tested it actually. I've just connected it to the coil just to test it, and it can drive the LED. But the question is, can it drive it after it's been for all these resistors and capacitors and everything? That's the question. It might not be able to do that anymore. If it can't, then I'll have to put an amplifier on here to do that. So anyway, that's where I'm at the moment. I mean, this will do for the drive, the actual pulse thing, but I just need something that processes a signal before it gets to this board, basically, so I can deliver the pulse at the right moment. Yeah. Anyway, that's all for now.